Okay, so let me get the one where the string was over here. So far on this scenario, we have A was 39, side B was 61, and A was 50. So we're going to set up the law of sines several times and get the various values. So I think you know how to do it. I will set up the first one, 50 over sine of 39 equals 61 over sine of B, and cross multiply, get sine of B by itself, and we end up with sine of B is 0.768, and B inverse sine would tell us that the angle is 50.2 degrees. So if this is 50.2 degrees, we can subtract these two from 180. 180 minus 39 minus 50.2 is 90.8. So we have that. And lastly, this is angle C. We can do sine, the law of sines again. We can say C over sine of 90.8 is 50 over sine of 39 and solve that. When I do, I won't show you that part. I came out with little c, side C, is 79.4. So that triangle is solved, at least halfway. So I showed you some of the work, and you can come up with the rest, I'm sure. But what about that other case that I mentioned when we were taking this and swinging it this way and creating a second triangle that had the same answers for the parts given? So we have A, then we had C up here, but B was in a different spot. So see the difference between AB, it was long when we swung it this way, and it was short when we swung it that way. So let's put in the values given from the problem. This is still 39. Across from it, this is A, is still 50. And B is 61 still. So none of that's changed. But you can see that the angles have definitely changed in this second solution. So how do we get those? Well, one way we can do that is to recognize that this angle, when we had these both drawn on the same picture, this angle and this angle are equal because these two sides were just formed by the string. Same length here, the same string, which was 50 long. So if these two sides are equal, then this angle and this angle are equal, because we learned in geometry that angles across from equal sides are equal. So if this angle equals this one, and this forms a straight line, since we were able to get that one, what was that, B 50.2? Is that right? Yep. So this was 50.2. So when we swing our green string the other way and make this one, this angle right here is easy to get. It's always the supplement of the angle over here. So this angle and this angle are supplementary. So 50.2 plus what will give me, so this is 50.2. Since this is 180 degrees, a straight line, we can get the angle that we're interested in, this one, and that's 180 minus 50.2. So when I did that down here, I'm going to get 180 minus 50.2, and that's going to be my angle B. And when I did that, I got 129.8. And I was expecting an angle greater than 90, called an obtuse angle, so that's what I got. Now I can subtract these two from 180 to get angle C, so that's quick. And when I did that, I got 11.2. And now we're in familiar territory again. So this is going to be much shorter than it was up here where we got a C of 79.4. So we're going to set up the law of sines. We're looking for side C and then we're done. So I'm going to say C over sine of 11.2 equals, say, 50 over sine of 39. And when I solve that using whatever algebra technique that you like to get C together, C by itself, then I got 15.43. As I promised, it was going to be shorter than it was up here. So that is one solution to this triangle, and this is another. So those angles, side angles, I'll always try to spell it that way, can be a pain in the side angle. All right, so let's go ahead and call that a night. I'm sorry it went on for so long. You have so many other things on your plate, but that's the way the old pre-calc lessons, how they tumble. So let's go ahead and actually take the 3 problems that we did in class. Tomorrow when we come in, we're going to pull them out again and see if not one of them might be the dreaded side angle, where we have to go back and evaluate it a little further to see which of these situations it is. All right, so that's all for today, and we will pick up at the law of sines tomorrow. Have a good evening. Bye.